Welcome back, everybody. We'll be looking at the concept of momentum and trying to understand what it really is. So to begin with, we're going to look at Newton's first law, which actually describes this idea of inertia. So an object will stay at rest unless an unbalanced force acts upon it, and an object will stay in motion at a constant velocity unless an unbalanced force acts upon it. So what these statements are trying to identify is an object's inertia. And basically, inertia is described within these two statements. It's the idea that an object wants to remain in motion or remain at rest unless some sort of external force acts upon it, which changes its direction of motion or changes its momentum so that it is moving in a different direction than before, or it's moving in some sort of velocity that is not the same as the velocity before. So an object's inertia is directly related to an object's mass. So you can think of it in terms of a large object. So if you have this large object, we'll give it some big mass m, and let's say you apply some small force onto the object. That small force will move this massive object, assuming there's no other external forces acting upon it, in this general direction. But it would move somewhat slowly because its inertia or its mass is kind of large relative to the force. Now let's say you have that same force, but you have a very small object or a smaller object to the larger object that has mass of capital M. And the object, this little object, will actually move a lot faster. And that's because it has less inertia or less mass. So a way to quantify this idea of inertia is by looking at an object's momentum. So momentum, all it does is quantify an object's inertia. So for instance, if this object was initially at rest, so its velocity was initially 0, and then when some force was applied to it, it gained some velocity v2, and it still had some mass with it. And the same thing could be said for this guy over here. So how do we actually quantify inertia? Well, we can use this concept of momentum, and momentum is actually defined in a mathematical sense. It is actually a vector, and we can say that the object's momentum, which is p, is going to be equal to the object's mass times its velocity. This right here is a mathematical definition of an object's momentum. And again, it just quantifies an object's inertia, the object's tendency to go in some certain direction, if it is in motion. So later on, we'll be using this concept in our dynamics problems to solve problems that relate to how an object's inertia, an object's momentum changes with respect to some force. And there's some questions that arise with this. Is momentum conserved is one of them. Can we develop an equation that is more easily calculatable than m times v? And how is that related to some external force F that changes an object's momentum? And how can we use this to solve problems and dynamics? So in a future video, we'll talk about that. But the main concept to get from this video is that the idea of momentum is trying to quantify the object's inertia and how momentum changes in correspondence with the object's inertia. And again, we'll be using the idea of velocity to describe that. So hopefully you understand momentum a little bit more than you had before, or maybe this was just review for you. In the next video, we'll derive an equation that is more useful than just saying that momentum equals m times v. And we'll use Newton's second law to derive that useful equation. So with that being said, I'll see you in the next video.